little bit about kind of my journey to how I got to my thinking today, and I want to do that because I think industry and academia can help us shape the way we go forward to do AI for the Army. So I got called out of the blue by the General Officer Management Office last summer, and they asked me about my background in artificial intelligence and system engineering, and they told me that I was on a short list from General McConville for a new job. So I obviously was very honored and accepted this job. But I didn't understand what the framework I was going into for the Army. I thought initially that I would be a matchmaker between technology providers, between industry, between the Army laboratories, and needs of the Army, and try to be able to match those two problems. I was all excited. I got to AUSA 1 year ago today, and I walked into this. And what did I see? AI everywhere. And that's what's happening, is that AI, as you know, is becoming a pervasive part of our society. In every system that you can think of, from self-driverless cars, to ride-sharing applications, to restaurant recommendation systems, to our healthcare systems, to audit readiness systems, and I can go on just like you can. The applications and domains span every area of our civilian society. These same areas need to span all our areas of our military systems. They need to span every battlefield system that we have, from our maneuver systems, for our fire control systems, to our sustainment systems, to our soldier systems, to our human resource systems and our enterprise systems. And trying to build that framework in the Army is going to be the challenge that we face over the next decade as we build our forces for 2028 and 2035. As you heard this morning, I want to call out some of the key points that Honorable McCarthy talked about on his keynote speech this morning about how we're getting there. And a key point of that is to understand our data. And if you take anything away from my talk today, AI is all about the data. And how do we want to get that data, and get that data curated in a way that's usable by our soldiers, by our research institutions, and by industry, so we can together create this AI ecosystem to go forward and bring all this AI technology into all our systems. So before I go forward, I'll go to the next slide, and I'll talk about where we came from. So National Defense Strategy 2018 talks heavily about AI and the AI technologies that we need. As part of that, the DoD CIO set apart 4 digital modernization strategies. So around cloud, C3, our command, control, and communication systems, cybersecurity, and the 4th modernization initiative was artificial intelligence. As part of that initiative, the DoD CIO set up the Joint AI Center. So the Joint AI Center was stood up last summer, and in response to that, the Army decided to set up an Army AI Task Force. Army AI Task Force was put under Army Futures Command as part of the Army Future Force Modernization Initiative. And that's, as my boss just came, General Murray, thank you, sir. We see AI as an enabling technology for all Army modernization priorities, from future vertical lift to long-range precision fires to soldier lethality. And I'll talk about some of these systems as we go forward and how AI is critical to these. After the Joint AI Center was stood up, again, we stood up our task force right at a year ago now, and we've been in existence for a year. We published our AI strategy about 6 months ago, and we're working to publish our implementation guidance at the end of this year. So if we can go to the next slide, please. So this will be an outline for my talk, some of the key areas we want to focus on. We want to talk about kind of our capabilities and requirements, what we call up here our early wins and our future designs. It's critically important that we enhance our current capabilities with AI. We have to look at opportunities to do AI today so we can show Army senior leadership of the great things AI is ready to do for our systems today. We have 4 key projects that we've started on this past year, and that will continue on next year, and I'll talk about those 4 projects in detail in the next slide. The other area that we had to focus on is part of the Future Force Modernization Enterprise. As part of that enterprise, Army Futures Command has as its charter to develop the next generation systems, all the Army modernization priorities that Mr. McCarthy talked about this morning, each one of those systems needs artificial intelligence. So what we have done over the last 6 months is we brought each of the cross-functional teams to our AI hub in Pittsburgh to sit down with our team, to sit down with academia and other researchers to understand what's in the realm of the possible for artificial intelligence in each of the cross-functional teams. So we brought in soldier lethality, we brought in future vertical lift, and each one of these we focused on those teams to look at what are some of the key capabilities. So for example, in future vertical lift, we looked at manned and unmanned teaming. How do we use off-platform sensors to do a better job of bringing in data, and how can we make those systems that they're using more controllable by our soldiers? Right now, we have autonomous wingmen for many of our systems. There could be sometime a UAV that's flying in with our attack helicopters. But right now, those systems have a very low-level capability for autonomous work. And our systems, what we're attempting to do is to enhance those systems to make them much more friendly, where the soldier doesn't have to spend all their time focusing on remotely piloting these systems, and instead can do other tasks as they go forward. Another key part we're looking at is soldier lethality. Soldier lethality is fielding as Mr. McCarthy said this morning, the Integrated Visual Augmentation System, or our IVAS soldier goggles that each of our infantry soldiers would be wearing. In the short term, we are fielding nearly 200,000 of these systems in the near term. Each one of those has significant amounts of high-tech sensors in board and processing and onboard integrated AI chips built into that system. Those systems are doing visual recognition for the system, they're tracking the soldier's eye, they're tracking the soldier's hand as they interface with the system, and they're tracking the soldier's voice. Each one of those systems uses a customized AI piece to do that. But not only is it built into the hardware, we need to be building it into the software as well. One key area that we've been brainstorming is just kind of fields of fire effect. We want to have an infantry soldier there sitting in their fighting position in a defensive operation, be able to look out into their field of fire and automatically be able to tell their squad leader or their platoon sergeant what is their field of fire. So I've taken this defensive fire position and this is what I see here. So this is my field of fire. Within that field of fire, there may be dead zones within that field of fire. From that, we want to be able to integrate that technology, be able to integrate that data from that one soldier's field of view, and then bring it up a level and say, well, here's the field of fire for my squad. And then how do we bring it up to the next level? Here's a field of fire for my platoon. So by the time it gets up to that battalion commander, they'll know exactly where their dead zones are in front of their defensive line. They'll know what their soldiers can put eyes on and touch right now, and they'll also know what they can't touch right now. That's the technology that we need to bring to actually enable both our individual soldiers, but also to get the speed that we believe that we need for multi-domain operations. So you see that in my next bullet here is for multi-domain operations. So as was said in the keynote this morning, multi-domain operations is our new warfighting paradigm that is an extension of air-land battle that changes that paradigm from a way of having interoperability between our systems to actually having convergence between our systems. The level of speed, however, to get convergence between all the domains from air, space, cyber, land, and maritime, to be able to synchronize activities between those at the speed that we believe that we're going to fight our future wars is going to require artificial intelligence. We're going to need help understanding how to deploy our forces on the battlefield. How are they going to be positioned at places they need to be defensible? So as we move our forces someplace, we know that they're going to be able to survive at that place and time for a given piece of time before they have to move to their next location. We know we'll need artificial intelligence to help create fire solutions. Right now, a lot of our fire systems are quite manually intensive. We have soldiers looking at systems. I recently went out to the National Training Center, sat down with an intelligence cell there, and looked at their products. They were sitting in a tent outside the operations tent. They had up their traditional maps that we've had up for years, and then looking for changes with Op4 had done overnight. With artificial intelligence, we'll be able to automate large portions of that process. So instead of having our traditional intelligence battlefield preparation of the battle, where we create potential courses of action, specifically enumerated courses of actions for our potential adversaries with actions and counteractions. We can create whole spaces, design spaces of courses of actions of how we want to lay out forces on the battlefield and use those. We'll be able to do enemy course of an action analysis and do this in real time so we can understand how we're going to fight the next fight and do this in a synthetic environment before we do it in an actual environment. Other key capabilities for multi-domain operations are as simple as our logistics systems. We know that having a large logistical base is not going to be able to work in the way we've been fighting our wars over the last 2 decades. We know that our potential peers are not going to allow us to have the luxury of having large forward operating bases. So we're going to have to figure out a way to use artificial intelligence to spread that logistical database out. So instead of having a hub and spoke model for our distribution system, we'll be able to use a much more mesh network where we'll get the right capabilities, the right support to our right units at the right time. So that's our capability set. For the last part of the other kind of key areas that the Artificial Intelligence Task Force is working on is how do we lower the barrier to entry for Army units and systems to be able to enable our AI systems. We need to be able to create an AI infrastructure for the Army. If we have every system that we deploy, so for example, we have our next generation combat vehicle, the types of information that we want to be able to get off of those systems to be able to do AI would include what's the logistic status of that vehicle? How much fuel do we have on hand? What's our weapon status? What's our weapons on hand? What's the maintenance status of that vehicle? We want to be able to pull data off of our targeting system. So it could be a main tank site, it could be a soldier rifle site, it could be a SHORAD sensor for our air defense systems. We get data off our targeting system, and then finally, many of these systems we want to be semi-robotic. We want to be able these systems to be optionally manned. We need maneuver data off these same systems. We don't want to be pulling off all that data from 4 or 5 different sensor systems from a score of different vendors for all these systems. We need a unified place to be able to pull this data off so our soldiers can go to one place, get that data, pull it off, and bring it up into the cloud so we can train on that data, do the data analysis, train our model, and push it back. And we'll talk more about that towards the end of my talk. We also need to create this Army AI data culture on how do we want to educate the Army on doing AI. We no longer see AI as being kind of the key point of just our data analysis experts, but as an all-encompassing enterprise for everyone in the Army. Believe it or not, we actually do that today. If you have a modern smartphone on you, you are training an AI system as you carry it around. Even if you're not interacting with it explicitly and using one of your systems and say, how well did I get you to your destination, or how good was this restaurant? Just by the fact of using the system, you're training an AI system. We need to be able to do that same type of training in our combat systems with our soldiers in the field. Our final kind of line of effort is to understand what are the conditions to do AI in the Army. What are some of the policies that are impeding us from being able to do this? How can we develop software faster and more rapidly? A lot of times, our traditional software cycle of deploying a new update to our IT infrastructure is a slow, laborious, and soldier-intensive process. We need to develop our AI systems so that they are as seamless as an update on your smartphone. Your smartphone comes up, it says, I have internet access here, and some system's going to automatically update that with a patch to your system, or even a new model for one of the AI systems on your phone. That same type of technology, we need to find how to do that in a secure manner on the battlefield. Next slide, please. So I'll go into some of the specific projects that we're working on this year now. So one of our key projects is called Mobile, Cooperative, and Autonomous Sensors. Here we're working with how to fuse data from multiple sensors on a battlefield environment to actually get better data. We're putting sensors on front of a surrogate vehicle that vehicle will be able to maneuver autonomously in the battlefield to be able to get a better situation of awareness of what it can see. From its main side, it'll be able to scan a normal general area in front of it. We'll also have a more refined sensor to be able to get a much more finer view of the world. We're using this on a lot of our systems as we go forward. We'll have a wide field of view sensor to get a general situational awareness of the system, and a much more narrow field of view for our targeting systems. If you think of our systems that we're building right now on our soldier lethality systems, we have those right now. With our IVAS goggles, it will give our soldiers a much greater field of view, both in day and night, to be able to sense their general environment. But when they decide they see an object of interest, they'll be able to use their rifle sight and look into that more specifically. As we build our next generation combat vehicle, we'll have that same type of 360 coverage around the vehicle, where the tank crew will have a much higher level of situational awareness of their system. And again, they'll have a single sight where their main engagement system to see forward in one specific spot. So having technology that be able to balance the field of view from a 360 or a much broader field of view and a specific camera at the same time is kind of a critical technology. And we don't have to just do that on platform. We can do it off platform as well. So how do we integrate sensor data from a UAV, from some type of aerial overhead system, or even a spatial system, to how do we pull data off that to better enhance that lethality of that next generation combat vehicle or any of our other armory modernization priorities. For our next major thrust is on predictive maintenance. There's a lot of small efforts going around, both in the Army and at the Department of Defense level, on how do we want to do better predictive maintenance as on both our legacy systems and our next generation vehicles. We're working closely with the Joint AI Center. One of their national mission initiatives is on predictive maintenance, and we're doing predictive maintenance on the 860 helicopter. But doing predictive maintenance is like many other AI systems. It's not just one algorithm. It's not just one piece. It's an entire ecosystem of pieces of where we get data off our platform. So in this case, we're getting data off our control systems off of a helicopter. So we're recording what happens on the helicopter, but we're also correlating that with other data associated with the maintenance of the helicopter. So we have the crew chief there. So the crew chief takes data off when they maintain the helicopter. So we have a source of data there. We have the flight envelope for the helicopter, so we know how it flew, and we can correlate the performance of the systems with, did they do any high G turns or any kind of maneuvers that may have damaged the system. And then finally, we have just the log records of the entire fleet, so we can then correlate the systems with what happened on this one specific platform with other platforms, both in the local areas as well as a broader fleet of vehicles. But to do that at scale is hard. So right now we're only doing that with one unit, with the 160th Special Operations Reconnaissance Squadron, and we're expanding that effort this year to work first at Fort Rucker and then other units around the Army. We also have initiatives to extend that to our other legacy systems, so from the Stryker to the Abrams, to find out where predictive maintenance may improve our readiness for those systems. But more importantly for predictive maintenance, we have to set the conditions for our next generation systems. We have to push it, and this is why we work closely with our other cross-functional teams to discuss how can predictive maintenance support future vertical lifts, support our next generation combat vehicles, support long-range precision fires, and how can we get those requirements in now, today, so in 2028, we can get that maintenance data off and have a more reliable system. For the third initiative is talent management. So the Artificial Intelligence Task Force has not only been working with Army Futures Command, we're also working with broader missionaries across the Army. So we're working with the CIOG-6, we're working with the Office of Business Transformation, and working with HRC to look at how AI can support the business enterprise of the Army. So one area where we had data readily available was in talent management. So the Army's been migrating their personnel and pay systems into a new system called the Integrated Personnel and Pay System Army, very unique name, over the last few years. So IPSA has a capability to help manage our soldiers and our officers. And the Army AI Task Force is working with them to create talent management algorithms. We're really just focusing on the algorithm piece because IPSA is providing that kind of ecosystem for the HR and pay data. And we've had a lot of, at least short-term successes there, showing the effects of a different algorithm and how that's going to apply to the promotion system. Our final thrust for this year is what we call intelligence support to operations, where we're using off-board data to look for peer competitors type targets. A lot of the great work that you may be seeing from Project Maven and the algorithmic warfare group under OSDI is really focused on analyzing full motion video, working on the counterinsurgency fight. So they're taking full motion videos of the traditional types of fights we've been fighting over the last 2 decades. For this project, however, we're looking at a more peer adversary fight for our multi-domain operations, and using imagery, how do we find targets of interest to us or objects of interest for our targeting systems. So for example, we would look at what are all the tanks we can see in a given picture, and how do we use AI to identify those tanks quickly with a high level of certainty, and then can pass those images over to when we see a tank, how do we push that data over to an operator so they can do that analysis and speed that decision cycle. So I'll go to my next slide. We'll talk about some of the infrastructure capabilities we'll do. Next slide, please. Is our artificial intelligence hub. So as part of standing up, as part of the directive establishing the Artificial Intelligence Task Force, we established an artificial intelligence AI hub at in conjunction with Carnegie Mellon University at the National Robotics Engineering Center in Pittsburgh. Here we bring in key technologies from across the country. We look at academia, we look at our FFRDCs, we look at the Department of Defense Lab, and we look at industry. We look at key technologies that we can use to help solve some of our future force modernization enterprise problems. This is why we're under Army Futures Command, and we work with our labs, we work with the cross-functional teams, and we work with all our partners within AFC, including the Army Applications Lab, to determine what are kind of some of these key technologies that we can move forward. So as an example, we spent, as I said earlier, we talked to each of the CFTs over the last 6 months. They came in and they gave us their problems. And we've got hundreds of potential areas where we can use artificial intelligence. And we obviously can't do hundreds of projects. But what we could do, we can synthesize kind of those projects into high-level capabilities that we need. So an example is aided target recognition. How do we take imagery data and find objects of interest for a specific application? And that's one of the key pieces of that part. From there, once we develop those technologies, we need to find a home for those technologies. And that's why we have technology accelerator hubs. That's why we work with General Thurgood, with RICTO, why we work with the rest with ASALT, and we find transition partners to move our technology. And luckily, we just had our first success for that, and we're working more this year. Next slide, please. So not only do we have to be that bridge between academia and industry, we've decided we can't have 50 different AI solutions across the Army, and that we need to make it easier for our soldiers to do AI regardless of what business application they're in. And this is why we're developing an AI ecosystem for use within the Army. So the Army has a number of big data platforms and big data initiatives that you probably heard about, from systems Army Cyber is doing to the Army Leader Dashboard. We need to be able to take data off those systems, curate that data, store that data in a centralized place, and then from that, be able to do our artificial intelligence development. We need to be able to build our models, be able to train those models, and have a model repository, and make those models accessible to the rest of the Army. From that, once you have developed a model, we have to actually deploy that model and push that out into one of our systems. We can be pushing that out into a business system, or we can push that out into a warfighting system. And that's what our ecosystem is going to do for us. And doing this at scale is going to be a challenge for the Army, because if you think about the number of platforms we have in the Army, it is incomprehensible at times. If you look at the number of IVAS systems, that will be 200,000 systems. If you look at a number of the Android devices, you may be able to see the handheld devices soldiers will have, that will be also in that type of number. If you look at the number of the command posts we have, if you look at the number of the mounted systems we have, they're all in even in a small scale brigade size operation, it's in the thousands, if not tens of thousands of end devices. So finding a way of taking that data from all those devices, doing some of the training at the edge, and moving that data judiciously up into the cloud without overwhelming our network is one of the key capabilities that we're working on this year with General Bassett's and General Gallagher's team under the Network CFT and PEO C3 Networks. I want to talk a little bit, as I spoke earlier, if you go to the next slide, please, about data and why data is important to us. At the top of this triangle is our senior leaders who need data. With the Army Leader Dashboard, we've rolled that out. We're being able to answer high-level questions to Army senior leadership quickly with that system. But we want to make those same kind of capabilities easier to use across the Army, and not just supporting our kind of the top-level leaders of the Army, but to be able to help data scientists throughout the Army be able to answer intelligent questions about their systems. From our data scientists, though, we only have hundreds of data scientists in the Army. And if you look at a lot of AI companies around the globe today, they typically have thousands of people helping them curate and manage their data. So we need to be able to expand that and have data scientists and data analysts be done in every system across the Army. So within each of our centers of excellence, we need to look at how do we train our next generation soldiers on using data analytics to be able to understand the AI systems that they're going to be using and interacting with on a day-to-day. And then finally, at the bottom it's the people who use the data and the people who are going to collect the data. There's a big initiative that we need to be able to collect that data for all our soldiers. And how do we create those systems, be it a tablet device or a handheld device or a soldier's goggle or even a rifle sight or a tank sight? How do we get that data collected and curated for the Army? Next slide, please. So it's kind of my last slide. I'll just talk about just some key high points for implementation. Because the scope and scale of these problems is so big, we're going to have to use cloud technology. We have soldiers, as you heard this morning, across countries in 20 time zones right now. How do we get data from all those soldiers pushed up? And the only way we can do that is using cloud technology. So having a multi-purpose hybrid cloud is key to this. But as you know, the Army is distributed, so we have to be able to do this in a distributed fashion where we get the data off of all our our platforms and our soldiers and pushed up into this cloud into a unified framework. We got to be able to train these models adaptively and quickly. A lot of the Army has AI technology that we've had for decades. However, we haven't been using it to the level that our modern systems do with the feedback loops that we have and need, and that's part of our initiatives. As I said, we need to be able to curate this data. We need an infrastructure that allows the flow of data and models between the source of the data to where we train the model and then back to where we use the model. Finally, as I said in the last slide, we need this AI-skilled human talent. And then finally, ethics and trust. We got to be able to use these systems so not only our soldiers and people using these systems understand their use and where they're fragile and strong. We also have to be able to have our public understand why these systems are so important for our soldiers to make them safer and more lethal and more efficient. So with that, I will stop. If you go to my next slide, and I will take your questions for the next 10 minutes. And if you use the mic, we'll all be able to hear you. So thank you.
Hello, my name is Anthony Harris. I'm a software engineer, specifically in RF as well as machine learning. You mentioned earlier that the Army only had a few hundred people who had the knowledge to handle data and to handle the technology. My question to you is, why is that? How do we recruit more people? How do you get more talent? And more importantly, how do you retain talent so they just don't go somewhere else like Google or Facebook or wherever?
Sure.
Yeah.
So that's a great question, and that question isn't just an Army problem. I mean, if you talk to every university, if you talk to all of industry, if you talk to other services, they all have that same problem. Part of it is developing a pipeline from initial entry through senior officers on how can they use those tools. Right now, it's difficult for us. So last May, I went to the U.S. Military Academy and saw all the great AI projects there. And almost every department there has cadets doing some sort of AI project there. But when they get to the Army, we don't have the tools where actually they can say and go out and do that AI piece. So bringing those tools out to the field is kind of a key enabler to our system. So when we get those soldiers and they actually get to the field, they can actually kind of do that capability. Right now, we have lots of great people doing AI in our labs, but it's typically done within one of our development labs that you may have heard in the last talk. But to operationalize this, we have to get it out to our systems. We have to get it out to our personnel systems, and then encourage soldiers to use that and train that on their own. But there are training systems out there. A lot of industry has realized that they have to train their own employees to do this because they know they just can't recruit them all. Luckily, a lot of these tools are becoming much easier to use. And a lot of the curation is really, a lot of the AI piece is really data curation. And that's what we got to focus on, especially in the short term. Thank you.
I had a question about integrating AI into the synthetic training environment. Could you speak a little bit to how that would work, and also to cybersecurity and protecting the treasure trove of data that the AI will generate from potential hacking?
Sure. So two very separate questions there. So with the synthetic training environment, I work with General Gervais's team to understand what their needs are. A lot of it is working with them so they understand the need to have high fidelity simulations in the synthetic training environment, so we can use those same simulations that we are building there to train not only our soldiers, but to train our AI agents. So part of that is to understand just how many of the systems we want to start building. Right now we're starting small, we're starting at the squad level, and that's why the initial integration really is within the synthetic training environment and a lot of our soldier systems, including the IVAS system, and how do we do those together at the small level before we extend those up to larger platoon, battalion, and then brigade operations. So it's going to be an incremental process as we start defining those systems. I know Soldier Lethality has a dozen things on their wish list for AI. Synthetic training environment has a similarly large list for those. For protecting our data, we concur. It's a critical piece. That's why we see a lot of the criticality of making sure that the cloud infrastructure we're using to store that data, or at least collect that data initially, is robust. We know that it's going to have to be a hybrid cloud. We know that some of that data we want to collect on the cloud and keep in the cloud. We also know some of this data that we're going to collect locally, and that data may stay locally, and it may never actually be pushed up into that commercial environment. So, more questions?
Afternoon, sir. My question is related to the cognitive capacity of soldiers. It's framed around the question in relation to IVAS, but it's equally applicable to many modernisation initiatives, and that is, is it your understanding that the ability for the average soldier that we're recruiting now and into the future, that their capacity to take on board information and make timely decisions is limited, and therefore we need to limit our ability to feed them information to that point where they're not overwhelmed? Or do you understand that we were going to, in the future, be able to increase the cognitive capacity of soldiers to be able to take in more information and make decisions without being overwhelmed? And if it is the latter, is there research and development going into training and education systems that are going to be delivered to be able to allow the average infantry soldier or the average junior leader to be able to make decisions and not be overwhelmed by information? Sure.
I mean, I think that's a great question. I haven't seen a lot of research so far that we're doing in the Army to the latter half of your question, the latter case where we're actually increasing the cognitive capability of our soldiers. AI, however, I think will help solve the first part, where we can synthesize a lot of data from a lot of different data sources and actually get the data that you care about because you've trained the system to say, this is the type of things I'm looking for. We know with a lot of the driverless car technology, they have a way of synthesizing the data from these multiple sensors, all to create this 360 view around or around an autonomous vehicle. Those same type of technologies we'll be using in the next generation combat vehicle. So when our soldiers are in the new next version of our tank, won't be overwhelmed by having 20 sensors on the outside of this vehicle that they have to monitor each one. It's creating that common operating picture using sensor fusion and AI. It's going to be a key way to not overwhelm our soldiers, because as you know, they'll get overwhelmed quickly. But that's why filtering is a key part of this as well. And how do we know that this is the data this one soldier needs and not everything? As you know, we use too much chat right now, and how do we filter those systems to be specific to your needs and not to the entire battle space? Thank you.
Sir, related to the previous question, all of this data will require the generation of decision support tools. So getting to the point of data overwhelm, what sorts of authoritative sources out there, and what are the things that we as developers should be looking at in terms of trying to design systems to make decisions, or at least promote decisions?
So the question was on authoritative data sources and how we're going to pick those. One of the big initiatives that the CIO G6, the Army G357 are all working right now is this migration of our legacy systems to the cloud. And that's why it's key as we go through this, we think hard about the end state. How do we want these systems to look like in the end, so we get this authoritative source of data in the right place with the right feeds in it, and we don't get too many of these systems. So when it's time to make a decision, everyone knows this is the right source, go to that source, and there's only one source for that particular piece. As we move forward and we become this data-enabled culture, as Mr. McCarthy talked about this morning, that's going to be kind of a key point, is the system engineering behind all that data. Right now, there's not quite the level of system engineering we need to be able to have this convergence of all this data, and that's why creating kind of this data ecosystem with AI tools enabled on top of it is going to allow soldiers to be able to answer the questions that they see fit. I don't think I can, or anybody's going to be able to know what questions the soldiers are going to have a dozen years from now, because that fight is going to be a different fight than we expect. But we need to enable them with the tools, so when they say, okay, here's a data question I have, I'm going to be able to answer it, and I'm going to have the skills to be able to pose that question, then find that data using AI technology, and then create that system so we're not overwhelming the commander. So, okay, one short question, or we're almost out of time. One last question? Ma'am.
Hi, Jen DiMassio with Aviation Week. I just had a timing question. How soon do you see these being available en masse to the Army? What's the kind of acquisition time frame look like?
So the acquisition time frame varies dramatically, depending upon what the technology is and what the hardware infrastructure for it. One reason to use cloud-based technologies is if you can do the entire deployment in the cloud, it can be very quickly. A great success story from earlier this year was with one of the hurricane response efforts. The Joint AI Center rolled out their humanitarian disaster relief capability over a weekend, where they wanted to do flood prediction for a potential hurricane site. And they were able to roll that out. They got the Title 32 authorities pushed out to them so they could use overhead imagery and look for potential flooding areas. And they did that literally over 72 hours. But because they had the technology ready to go, and they just needed to get it out to one of the National Guard units to be able to deploy it. For systems that are on our short-term horizon, and you've heard me talk about at least 3 times now, is the IVAS system. Because we're deploying that IVAS system in the short term over the next few years, and we're rolling it out at scale to be able to have enough, and that will give us this quantity of sensor data that we can train AI algorithms on it. So that's in the short term. Longer term is the 2028 time frame that a lot of the cross-functional teams will be talking about, or even 2035. So, well, thank you very much. It's a pleasure and honor to speak to you all, and look forward to continuing this conversation at the Media Roundtable immediately following this in room 205.